In the previous video, I discussed real versus nominal interest rates. Real rates adjust for the rate of inflation and therefore tell us how much more goods and services we can buy with the money we have. Nominal rates just tell us how much more money we'll have. And what's the relationship between the two? Well, Irving Fisher, a well-known economist, came up with this theory or this equation that is widely accepted as and has become known as the Fisher effect. And it looks like this. We say that 1 plus the nominal rate, and I'll write down the notation, okay, capital R is the nominal rate, is going to equal 1 plus the real rate, little r. I've been using little r mostly to just designate the interest rate, but here we're going to use that for the real rate, times 1 plus h, which is the rate of inflation. So let me write down the notation here. Capital R is the nominal rate, little r is the real rate, and h is the inflation rate. If you expand this equation, if you do the multiplication, you'll get 1 times 1 is 1, and then you'll have r times 1 is r. Well, let me just do that for you. Okay, so you should have 1 plus r, and then you'd have h times 1, sorry, that's an r, plus h plus r times h. Right? And if you subtract 1 from both sides, so I'm going to move down here, you get that r equals the real rate plus the inflation rate plus this term that's multiplied together, r times h. Oftentimes what we do is we just ignore this. We just get rid of this because it's very small. These are percentages. If you had 0.03 times 0.02, it's going to be a very small number, so we sort of get rid of that and we say that the nominal rate r is approximately equal to the real rate plus the expected rate of inflation. So let's look at an example. Suppose it's the case that we have a real rate equal to 5% and expected inflation is, let's say, 3%. Well, if we use the real equation, so we say that 1 plus r equals 1.05 times 1.03, so let's work that out. Let's see what we get. 1.05 times 1.03, so we get 1.0815, and then we subtract 1 from both sides, so we'll get that the nominal rate is equal to 0.0815, or 8.15%. Okay? If we use the approximation gives us a pretty good guess. It says it's the real rate, which is 5%, plus the expected inflation rate, which is 3%, which is 8%. So the approximation gives us a pretty good guess as to what the nominal rate will be, and we usually use this. This is really quite common for us to use, is this approximation, because it's good and it's much easier to do. You don't have to do the multiplication. You know, the 0.15%, while it matters, it's not that critical, and this is a pretty good approximation. So this is a useful model for understanding the relationship between the nominal rate and the real rate. And of course you can do the opposite case. If, for example, you knew what the nominal rate was and you wanted to figure out what your real rate was, your real rate is going to be approximately equal to your nominal rate minus the expected inflation rate. So if you're getting a 10% return, a nominal 10% return, and you expect inflation to be 4%, then 10 minus 4, you would get a real rate of return of 6%.